Hi, welcome to another week of the Chem 1212 lab here in North Georgia. This week's going to be a little bit different in the fact that we're kind of going to start like really kind of a multi-weeks kind of semi-project. The reality is you should be able to do pretty much all of the experimental portion of the lab this week. And then you're going to kind of be taking some time over the next couple weeks to actually kind of write a formal report on it, which is something that is new that you guys haven't done. And really I'll probably spend most of my time here in this video talking about kind of some of the expectations for that formal report. Now, in terms of the lab itself, you are going to be taking a look at the enthalpy of neutralization. And hopefully that kind of sounds a little bit familiar because you actually did do a lab, and if you took 1211 lab here at least, you probably did an enthalpy of neutralization lab in 1211. So there are going to be some similarities there. Now, in terms of what you're going to be doing kind of in the lab itself, or if you've looked at CSE Pub, the lab itself, you're going to really try to verify other people's results. So kind of the situation that's laid out in the CSE Pub online reading, you'll see that they talk about kind of a hazmat team report responding to a chemical spill, that they did a neutralization reaction, and that in general their observations are that they get a certain temperature change based on the amount of HCl and NaOH that they react. You guys are basically going to be kind of breaking off into groups and really kind of trying to do a handful of some different experiments, really trying to confirm the results of the hazmat team, but also looking at trying to explore and really get a better kind of feel and understanding for how heat, enthalpy, and temperature change for these reaction solutions are really all related to one another. Because they are all related to one another, but they are not the same thing. And so they all have kind of slightly different things that they do depend on. And that's really one of the big takeaways that we want you guys to really be able to understand kind of coming out of this lab, is to really understand how those things are related, how they are different, and what things impact one or the other. Because like I said, they all will be affected a little bit differently by different things. And so this will require, since we're really kind of, in some ways, redoing one of our experiments from the 1211 lab, this will require a little bit of review of some things you probably saw in 1211, which is probably for the best because we do have our final exam coming up in less than a month now that everyone's going to be taking that has 1211 stuff on it too. And in addition, we'll be seeing a lot of this material again in chapter 19 also before we wrap up this semester in 1212. So it's probably good to see some of this stuff a little bit again. So to kind of review some of those topics that we will be using again in this week's lab, one of the big ones is going to be enthalpy, right, delta H. And you can really think again of delta H or enthalpy. It's kind of the energy change that happens during a reaction or just any process that comes from really heat exchange. And if you're thinking about chemical reactions, the best way I like to think about it is delta H is your energy change that comes from breaking and forming bonds. That's probably the best way I think of in terms of ways to think about enthalpy for a chemical reaction. Now, from a calculational sense, delta H is really just equal to Q as long as we're at constant pressure, where Q is heat. And for this lab, if you're working in the lab doing this in kind of any open air container, you're going to be at constant pressure, like just a general atmospheric pressure. Now, the other thing you will see if you're looking at a very specific reaction, like what we will often do kind of notation-wise and unit-wise, is if we're looking for delta H of a reaction in particular, we'll usually find it by taking the Q or the heat of that reaction divided by the moles of the limiting reagent involved, so that your delta H of reaction will usually have units of kilojoules per mole or maybe joules per mole. And so that's pretty common, and it just gives us kind of a standard energy change per amount that's reacting so that we're able to kind of describe things a little bit more precisely for the reaction that we're looking at. Now, the other piece of kind of just, I guess, background information that we want to review from 1211, it has to do with calorimetry. And really, the calorimetry is all about tracking heat and where energy is going. And the fact that if something is losing heat, something else has to be gaining that heat. And that those two should be equal to each other but opposite in sign, right? And sign notation-wise, if you have a negative Q, if Q is negative, that means you're losing energy, right? And that's why heat gain should be negative heat lost. Is because if the heat lost is negative, then for these things to be equal, heat gain should be a positive value, so that's why the negative sign's in that little equation there. Now, for our reactions that we're doing this week, you're going to be doing neutralization reactions, which are typically very exothermic, right? And if they're an exothermic reaction, that means you should be having the reaction itself lose the heat. And so our reaction's giving off the heat. There should be a negative Q for our Q reaction. And then that means the water is then gaining the heat, which is then going to be a very positive Q instead. Now, for this week's lab, we are going to do one thing that's actually a little bit easier than the 1211 lab. In the 1211 lab, we talked about calorimeter constants, and we actually calculated a calorimeter constant for this particular experiment and used it for us to look at the enthalpy of neutralization of a reaction. Well, now that we kind of put you guys through going through that process, those calorimeter constants are small enough in this case that we can, for the most part, get away with ignoring them. And so we are just going to pretty much ignore the calorimeter constants or the heat loss to the surroundings in these cases. They should at least be close enough to what the real results are that we'd expect for us to be able to see all the patterns that we should be able to see. So for our calculations, and really what you're doing this week, we're going to have heat gained by water and heat loss by the reaction. And those two are going to be equal but opposite in sign as you're kind of doing your calculations. And that's really all the review we're going to go through here. You might get a little bit more in some of your pre-lab lectures that you can talk about. But really part of the goal of this lab is really you guys do a little bit more on your own. We're not really going to have a direct procedure that we're giving you for this lab. We're actually kind of expecting you guys to kind of look back a little bit on what was done in 1211. And if you didn't take the 1211 lab here, that's fine. We'll have a couple procedures of that 1211 lab actually laid out in lab when you come this week so that you can kind of review those and look at kind of what did you do in the past when you were doing this experiment to give you guys a little bit of kind of a help to remember what was done so you can do a decent procedure for this week's lab. Now, the goals of the experiments you're going to be running. You're going to be performing kind of a series of neutralization reactions, like 5 of them in total, that have varying stoichiometries or volumes of the acid and base or concentrations of the acid and base, and really just recording temperature change data. Like how does the temperature change each time? And the idea is you're going to be calculating the enthalpy of neutralization for those reactions for each trial and seeing like does the enthalpy of neutralization change for each of those trials based on those factors. But you're also, besides just the enthalpy of neutralization, also going to be looking at how heat and temperature change also change as you do different things with stoichiometry or the volumes of your solutions or the concentrations of them. So there's a lot of different kind of moving parts here, but the end goal is really taking these 3 things right here, the heat, temperature change, and enthalpy, and really trying to figure out like what things really affect each of those, and also kind of how those 3 things are all still related to one another. That's kind of the big understanding takeaways we'd like you guys to get. And that's also part of the purpose of having you write the lab reports I'll start talking about here in just a minute, is so that you can actually then on paper get used to kind of talking about these things from kind of a scientific perspective to really kind of show that you understand what's going on with them. And as you're doing this, should be kind of a nice 1211 review, as I mentioned before, on some things with energy like enthalpy and heat. Those things will both pop up again a little bit in chapter 19 that we'll get to pretty shortly in the lectures. And also, hopefully this week, you will be doing some dilutions, and that's something to kind of pay attention to because almost all of the acid and base solutions that are going to be kind of set out for you in the hood for you guys to work with, probably none of them will be the concentration you actually need to use for any of your trials, so you will be having to do some dilutions this week. So hopefully it'll be a good review, just kind of the general solution-making processes. And so if you have questions on that in the lab, please do ask your instructor, your TA, but do realize these are things you really should be kind of comfortable being able to do going forward, because making solutions is a pretty general skill that anyone coming out of general chemistry really should possess. All right, now the assignments for this lab, there's actually going to be 2 of them. All of the experimental portion is going to be done in groups of about 3 or 4, depending on the size of the whole lab section, maybe a group of 5 here or there if your professor's okay with that. But typically we try to do things in groups of 3 or 4, and each group as a whole will submit 1 lab report to their lab instructor. But each student will still individually answer the questions that are up on CSE Pub for this lab. So this 1 lab actually is 2 lab grades. 1 lab grade for the assignment that's on CSE Pub, 1 lab grade that's kind of the group grade for the report that your group is going to submit. Those are so your 2 lab grades for this 1 individual lab. Now, you will have a couple weeks to complete everything for this lab. So this week in lab, the goal is really what I think all of you should really work for is to try and do all of the experiments you need and get all of the data, and at least take a quick look at them and make sure the data makes sense. And then you're going to have the next couple weeks to actually work on the lab reports for everything, because the actual lab reports themselves will be due during the last week of class after Thanksgiving break. So you're going to have plenty of time to work on these reports. They're not going to be due just the week after, like is kind of the normal for our other labs. We want to give you time to work on these things together and kind of get a feel for writing these things and ask questions of your instructor so they can help you as well as you get used to kind of writing some of these reports in a different format maybe than what you're used to. All right, for the written reports, every report's going to have the kind of the same general sections to it. The first of those sections is going to be something called an executive summary, or if you've written reports for kind of different science classes in the past, really it's kind of an abstract is I think the best way to really think about it. And I'll detail each of the individual sections and what their contents should look like here in a moment. But your other sections, you're going to have kind of an introduction where you're really kind of talking about what's the general purpose, what are some of the things that you're doing, maybe a little bit of background information from some theory about what people might need to understand and know what you're talking about. And then you'll have either kind of a procedural / experimental section where you're really describing what was done specifically or what you guys did experimentally to do the experiment itself and kind of get your different results. Then you're going to have kind of a data and results section, which you can either have as separate sections or kind of combine them together. And I'll talk again, like I said, about those in a second. And then you'll have kind of a general wrap-up or conclusion section that we'll have. And of these, really, these last four should all, or kind of that I have highlighted here, should all kind of flow together. The executive summary or abstract's kind of its own standalone thing that should have a lot of overlap with things that are in your conclusion section, but also have a little bit of kind of minor details from some of the introduction purpose and a few things maybe as far as like how experimentally you did your procedures. All right, so on that note, the abstract portion, your executive summary, it's, like I said, a brief overall summary of kind of what you did and what the findings were. In particular, you should have a really brief summary of kind of what you did experimentally. Does not have to be long, like just 1 to 2 sentences. Keep it very, very brief. You're going to have a whole experimental section later that details that in a lot more kind of fine detail. And so here, just kind of stick to the basics, what exactly was done, and then move into, all right, what did you really figure out? And in particular, I've highlighted 4 questions here that CSE Pub has pre-lab reading that it kind of introduces these questions as things that your executive summary or your abstract should really, really focus on. And these 4 questions should all be addressed in some capacity. Right? How are the volumes going to impact heat generated? How do the concentrations impact the heat that's generated? Does the excess base impact the heat that's released or the enthalpy for that matter? And then the last thing, what happens if you switch sulfuric acid for hydrochloric? Like, what does that do to enthalpy and heat as well? And so it's mostly focused on heat here. Your conclusion section a little bit later, you'll see we have some similar but slightly different questions that are really kind of highlighted even more particularly on kind of everything in terms of heat, enthalpy, temperature changes, like how are those things related that your conclusions will touch a little bit more on. But these are kind of the main ones that we want addressed in the executive summary in particular. Now, into the paper portion itself, kind of some background, introduction, or purpose information. I would expect everyone to have kind of a brief introduction to what exactly the hazmat team situation was and what they did and what their general finding is that you're trying to kind of verify or confirm. And then a brief description of what your kind of goals of the experiment are in terms of, what are you going to do to try and verify what the hazmat team figured out? Like, what do you expect to see and kind of how you're testing that? And then also, if there's any kind of theory background that people need to have an understanding of to know what you're doing in your calculations later, you should probably have maybe a couple sentences or even a paragraph kind of describing kind of what some of the theory is that's going on here that people will need to know to understand things like calorimetry or enthalpy or things like that as you're talking about those terms in your conclusions or other places. Your experimental and procedure section, this is probably the section that's most different from probably anything you're used to kind of writing in general. And the reason for that, it's kind of a different format and style in terms of how you write this section. You write it in what we call past tense third person as you're describing how your experiments were done, and they should be very specific to exactly what you did experimentally, as much so really as specific as you can be. And to give an example of what we mean by kind of past tense third person, you would say something like the acid and base solution were mixed together and stirred for 5 minutes while constantly measuring the temperature. And you'll notice there's no personal pronouns in any of this, right? There's no I did or we did or the experimenters did or we measured. It's basically, just, the solution was mixed, not we mixed the solution, which are very distinct differences. And that is kind of stylistically, if you look at pretty much any journal article for like biology, physics, chemistry, like this is kind of this past tense third person. That's the typical formatting for that kind of procedural or experimental portions that you're typically going to read. It should be in paragraph form also. It is not a bullet list. You are not really writing a procedure for someone else to follow. You are writing kind of a documented written description of what you did. So it is past tense in that regard. And so do keep it kind of paragraph form. Try to stick to this past tense third person as best you can. And if you have questions about what you're writing in terms of if it's the right kind of tense and from the right kind of perspective, please ask your instructors. They can take a look at it to make sure your kind of style is of the appropriate type before you turn things in. Now, The next section after that, usually going to be data and or results, maybe a little bit of discussion, although a lot of it's probably going to be in the conclusions for this particular paper. So for the data section, if you want to have data and results combined, that's perfectly fine. That's pretty normal for a lot of different people you're going to have to write lab reports for, kind of in the different branches here of science. But the biggest thing, most of your data, if possible, you want to put it kind of in table form so that you can display it all really easily. Right? You don't want to try to have to write out all your data in words and kind of paragraphs. That's just going to be really messy and hard to really see it all easily. So tables are your friend. Use tables to show all of your data and kind of relate things together a little bit easier. Likewise, for the results side of things, for your part of your results, you do want data table 1, which is the very bottom table in your CSE Pub pre-lab reading, kind of completely filled out. And you're going to have to do some calculations to fill that table out. And so we also want to see not only just that filled out table, but just kind of at least one sample calculation for each calculation type that you have to do. And we want that done preferably electronically to help kind of get you guys familiar with using equations in Microsoft Word, which is actually a lot easier than you might think. You can just go insert equation and start, there's a bunch of different kind of things that you can click or options there and kind of menu bars that'll pop up. It's not all that hard. It's relatively user-friendly to kind of get used to using to be able to put equations into your reports. But we do expect to see those sample calculations to go along with those data tables. And like I said, if you want to have a little bit of discussion about some of your data, like if some of it doesn't make sense, if you want to mention that a little bit in this section, that's fine. But really most of the discussion, at least for this report, is going to happen in the conclusions. A lot of other papers you might write in the future, your results kind of often gets combined almost with a discussion as well, where you'll actually kind of see kind of the general results discussed and kind of gone through in a little bit more detail in terms of what they mean. Now, for this report, though, conclusions, we're going to be doing most of that. We would like a summary of your general results. It's like what are the kind of end results that you saw, but in particular, what we want you to focus on is answering these 3 questions. And so how does volume impact heat, delta H, and our temperature change? How does concentration of the acid and base you're mixing affect those same things? And how does switching sulfuric acid for the hydrochloric acid change delta H and heat and temperature change? And we're really trying to get an understanding of, what are each of these different things really truly affected by? And we want this kind of whole section written in kind of a general paragraph or prose form. It should not be a bulleted or listed like question answer thing that's numbered or bulleted in any way. Just normal paragraph form, but address these 3 questions and do so in a way that really kind of shows you understand how delta H, heat, and temperature change are related, because they are not all the same thing, right? The temperature change for 2 different reactions that you see in your water might be the same, but the total amount of heat that was involved might be different. And so that's what you're going to have to kind of try and look at and see from your results and try to really be able to talk about in kind of a nice, coherent, kind of concise fashion to be able to describe how are those things actually related to each other and what are the things that kind of affect each of those, like delta H, heat, and temperature change, like those different things we're trying to calculate throughout the course of this lab. All right. I think that covers most of the general kind of quick expectations for the individual sections for your written reports. As things kind of go forward, if you have questions while you start working them with your groups, please ask your instructors, and we can try to kind of answer questions, like particularly for writing like the experimental section, because it is a little bit different. But we can help out as best we can with this process. We know a lot of you, if you haven't taken a lot of other science classes, probably haven't written a lot of reports. So this is kind of some of you might be your first kind of foray into doing that, and that's perfectly fine. Which is why if you have questions, please ask. We will be more than happy to help you. But that's pretty much all I have for this week's video. Hopefully everyone has a good week, and we will see you next time.